Alright, how's it going? We're taking a look at Zombies Ate My Groupmate, the activity for lesson 4.1. First piece of information we have is that there's been some sort of outbreak of a virus at Pueblo High School, and that on any day, each infected person infects one other person, right? So, information 2. After 3 days, 56 people have been infected. Okay, so if you want to go ahead and get started without any hints, you should pause the video right here and do that. Okay, otherwise, the two things to consider, right, is that this first piece of information, if each infected person infects one other non-infected person, and if there were 10 people, those 10 people would infect 10 people. If there were 100 people, those 100 people would infect 100 people. Okay, so however many people there are on one day, that's how many people infect, for that day. Okay. So when we add something to itself, that's doubling. So we have a doubling pattern here. The population doubles every day. Right? The other thing is, how do we keep track of all this information? If it's going to be doubling, and we know that after 3 days it's 56, okay, there we go. We're going to want a table. Okay. So problem statement number 1. Okay, how long until the whole school is infected? If we take a look at a quick search of the internet, Wikipedia is going to tell us that the population was 1,663 a couple years ago. Okay, maybe you want to round that up to 1,700 students. Okay, it was about that this year. Maybe you want to take into account, support staff. Okay, there's other people, teachers and whatnot. So you could use any of these values. Okay, 1,700, 1,800, 2,000, it's all relative. All right. What's important is how you investigate this problem. Okay, so like I said, if we take a look at a table, right, with time being the number of days since the infection has started, or that we've noticed it, and that I is the total number of infected people, right? We know that after 3 days there were 56 people infected. Now, if we go ahead and add 56 to itself, we're going to get 112, right? Or if we double it, we get 112. We can double that and get 224. Okay, double that again, right? So we could see that, we're adding 56 here, and then we add the 112, right? We add 224, 448. Okay, we can even go backwards, right? If we know the pattern's doubling, we can just divide by 2 going backwards, and the pattern still holds true, right? We see 28, 14, 7, so if those 7 people that we started with, right, we see there's our initial value, 7 people we started with infect 7, that becomes 14. Those 14 people infect 14, that becomes 28. Okay, so this pattern definitely holds true. So we could see that it keeps going, and after the first week there's 896 people infected, and that's not quite enough, right? So we need to go another day and end up with 1,792. So again, depending on what your thinking the population of Pueblo is, if you said it was 1,663, okay, students, then you're going to want to say that it's 8 days, okay? If you rounded to 1,700, well, it's still 8 days. Okay. If you said 1,800, well, you're going to have to go again. If we double again, that's going to put us up, in the 3,800 range. And so, sorry, about 3,500, my bad. Put it about 3,500, and so that would be 9 days. Okay, so again, whatever you started with is not a big deal. It's how you got there, right? And ultimately, exploring this pattern that we have here, right? That every day. Okay. So the other thing, so that's problem number 1. Okay, how long is Pueblo going to be infected? All right, and then problem number 2, how long until all of Tucson infected? Again, a quick search of the internet's this macro trends gives population of 982,000 people for 2020. Okay, so yeah, maybe you want to use that. Maybe you want to use 1 million people, right? So just knowing that it's doubling, we could even start after day 8, 1,796, right? And we could plug that into a calculator, and we can keep multiplying over and over and over by 2 until we get something, So, doing something like that will show us that after 16 days, there were 458,752 people infected. Doubling again is 917,504. Still not quite enough. Okay, so again, really no matter if you've rounded or you use 982,000, it's going to take 18 days. Okay, somewhere between the 17th and 18th day, everybody's going to become infected. Okay, so that's not very long. It only takes, that's less than 3 weeks for everybody in Tucson to become infected with something like that. Okay. So those are the big ideas here. Okay, we want to take a look at this pattern. The big thing that you should notice in exploring this is that the pattern is not linear, right? When we take a look at our first differences here, okay, delta I, the change in the number of infected, right, we could tell that is not constant. Okay, so the pattern of adding definitely is not linear. Okay, it's not constant, not linear, but the pattern that we noticed is a multiplicative pattern. Okay, times 2, times 2, times 2. Right? So this is a different type of pattern that we want to start to explore as we proceed. So look for that in the lessons to come. All right, so do this activity. If you've got questions, go ahead and bring those questions to a Zoom session. And other than that, good luck.